दोस्तों जय हिंद जय भारत नमस्कार. In last few sessions we have already discussed the effect of capacitive current generated by the VSD application for the motor, especially for the long run cables. In continuation with this, during the commissioning of the VSD to motor, when we are commissioning a variable speed drive with a motor with especially a long run cable, the distance in 200, 300, 400 plus meters, how can we avoid this capacitive current? That is the topic what we need to discuss today in this particular small session. So how can we reduce that capacitive current, and what are the chances of a capacitive current when we are laying the cable? What precaution we are supposed to take? That is the area of discussion. Today we discuss how to lay a cable. Can we avoid this capacitive current? Answer is yes. So this is a small diagram. From the left hand side there is a inverter. I shown only a VSD inverter, and from the VSD inverter there are three phase. Red is L1, yellow L2 and blue is L3. And from the L3 in between I have shown that particular long distance cable, and at last it is terminated to the motor TB, and motor is now running. It's a fantastic. So now if you see in this type of arrangement we have a multiple long run cable. That is the second area of concern. When we are commissioning the VSD with a long run cable with a multi-run cables, you can see here as per the Fleming right hand rule, it's supposed to generate the magnetic field. And in this particular case, in such type of arrangement, when we have connected L1 to L1, L2 to L2 and L3 to L3 in a simple parallel way, you can see here multiple run cable, all the run cable are supposed to generate the magnetic field. And as per this particular right hand rule, you can see this field is additive in nature because we have laid the cable in a wrong way. And all this magnetic field are in additive in nature, and in the same cable path we have a low voltage electronic devices also, and these devices are supposed to work on extremely low voltage signals. So for an example, 24 volt DC. Now the same cable is been laid inside by to the VSD run cable, and this VSD run cable are supposed to generate a strong magnetic field because we have laid the cable in a wrong way, like that L1 directly connected to the L1, L2 and L3 in a simple way. Now if you see this particular is if you see such type of arrangement, it will supposed to generate a strong magnetic field. And if the load on the motor, when the load on the motor is increased, the current passing through the cable is also increased. And if the current passing through the cable is been increased many times, this strong magnetic field will affect the side by low voltage electronic devices. And if it affects the side by low voltage electronic devices, there are chances of tripping of those devices, and it is considered as a huge production loss for this such type of arrangement. Now you can see the tripping of side by system, you will not find anything wrong, and if you reset this electronic device, it will work for a few days, few months. Depends on the how much magnetic field is being generated. Indirectly it is depending the motor load, at what load motor are supposed to run. If the motor is running at a lesser load, the field is not that much strong to affect the side by cable. One beautiful day, the load will be increased. It generate a strong field and it will trip the electronic device. You will never find a single fault on this type of arrangement. That is the biggest headache for the user. So kindly note down such type of arrangement are to be taken care, especially when the long run cable with a multiple run arrangement. So this is called a production loss and a huge loss to the user also. So how can we avoid such type of arrangement? The beautiful way to connect, if this type of arrangement is there, you can see here. The second problem is, now let me try to explain the second problem. With a simple run, simple straightway connection, you can see the capacitive current magnitude is also increased. Now if you see this, the each cable is supposed to generate the capacitive current, and with the increment of the cable length, you can see here all these are in additive in nature. And one beautiful day, your inverter has to handle the load current with the capacitive current, and this is because of the long run cable with the capacitive current. There are spikes are being observed in the current supplied by the inverter, and one beautiful day once it touches the overcurrent limit of the inverter, our inverter will drift on VSD overcurrent fault. We will not find anything wrong at the VSD end as well as the cable as well as the motor. Once we reset this particular fault, it will run for a certain time period, and one beautiful day again it trips. So this is the second headache for the user. uh, Unwanted overcurrent fault will be observed by the VSD inverter. So how can we, what are the solutions? How can we avoid with our physical cable laying practices? Beautifully, you can see here if you are running with a multiple long run cable, the first one is you can see this type of arrangement. This is called a transposition connection from the cable at the VSD end, and same cable termination needs to be take care so that the field generated by the each and every cable run will be nullified each other, and at last it will cancel each other in a long run, and the side-by equipment will not see any type of abnormality. Even though it's a sensitive device, your cable will be well protected, running even though in parallel to the VSD run cable. So this is called a connection at the VSD end, and we have to change the cable connection, just I have shown, so that it will cancel the effect of each and every field R, Y, and B. Both all the three will cancel each other magnetic field, and at last it will nullify each other effect. This is the first advantage by doing the cable connection at the VSD end as well as the motor end. The problem for the user is you need to note down the cable connection when you are doing for the PM and troubleshooting activity, but it's giving a fantastic help in the long run. So no need to worry. You can manage this particular good advantage by doing the trans connection of the cable at the VSD end as well as the motor end. The same advantage you can see here what we have discussed in the capacitive type of current. You can see here with such type of arrangement, the capacitive current also will nullify each other, and at last your capacitive current is absolutely remains nearer to the minimum value, and you can never face VSD overcurrent fault also. So this is two biggest advantage by doing the connection at VSD end and at the motor end, what I have mentioned. That is called a transposition of the cable, and you will get a fantastic result, so that you can avoid a capacitive current and at last the overcurrent fault by the VSD. So this is the small presentation. We will continue with the such type of discussion, sorry, and in future we will meet soon with some different interesting topic. This is for the this video is only an educational video. Those who want to learn the VSD, there is no relation with any brand or any make. Thank you. Dhanyavad.